All right. So fungi, similar to bacteria, they do have a cell wall. Now the structure and خلينا نحكي components of the cell wall in fungi is different. It's composed mostly of monoproteins, glucan, and this is a target of, or its synthesis is a target for one of the drug classes اللي راح نحكي عنهم. فdefinitely راح نحكي عن its structure. And the enzyme that is responsible for the synthesis of this structure, which is the glucan, واللي احنا ممكن نعتبره موازي للبيبتايدوغلايكان في البكتيريا. All right. Now that enzyme responsible for its synthesis is also a target for one of the classes اللي راح نحكي عنها. The majority of the antifungals that we will be focusing on are those which target ergosterol and ergosterol, let's say, synthesis. Okay. فراح نحكي definitely عن those which bind to ergosterol and how by binding to ergosterol they will affect its, let's say, or the overall structure of the fungal cell membrane. And for sure راح نحكي عن that biosynthetic scheme which is involved in ergosterol synthesis and the drugs that do target this biosynthetic pathway. Okay. هلا for this first class اللي راح نحكي عنه, those antifungals that target the ergosterol structure and the ergosterol biosynthesis are the polyenes and the azoles, okay, and allylamines. Now, with polyenes, structurally, they bind, or let's say they have massive structures that do bind to ergosterol. And as for the azole and allylamines, those, let's say, drugs, they inhibit one of the pathways or one of the steps that are involved in the ergosterol biosynthesis. Now, before we talk about those two classes, خلينا نحكي هلا عن ergosterol and what is the ergosterol structure and what does it do. Ergosterol, which is here represented, let's say, by those orange structures, is, as you can see, structurally is classified as what? It's a steroid, okay, or it has a steroidal backbone. Now, it is part of the structure of the inner cell membrane, very important for the fluidity, elasticity of the cell membrane. It plays a major role in the permeability of the cell membrane. Also, it is very important for خلينا نحكي ال binding of the integral proteins اللي هي يفترض إنها تكون موجودة عندي in the cell membrane structure. Now, the ergosterol, all right, has this structure which is relative to our steroid that is involved in our cell membranes, اللي هو الكوليسترول. Okay? هلا, if you look at the two structures of ergosterol and cholesterol, what are the variations between them in terms of structure? Yes. Just one double bond, the variation بينهم? Yes. There are two double bonds in the structure of ergosterol that are part of its structure, making it different from cholesterol. This is very important for the selectivity of polyenes to ergosterol versus that of cholesterol. Ergosterol is a compound that is synthesized in fungi, all right, using or starting from squalene. There are many enzymes involved in its biosynthetic pathway. أنا بس راح أحكي عن two steps واللي هم يعتبروا targets for some of the drugs اللي راح نحكي عنهم فقط. هلا أول شيء بيصير عندي ergosterol biosynthesis is that squalene binds to squalene epoxidase, which converts it into squalene epoxide. What it does, it only binds to squalene and, let's say, epoxidase, let's say this double bond, giving rise to the epoxide form. Later on, squalene cyclase is the one responsible for binding, let's say, the carbons, eventually giving rise to the backbone of the ergosterol biosynthesis, واللي هو اللانوsterol. هلا, that first step, which is conversion of squalene to its epoxide form, is catalyzed by squalene epoxidase, and the epoxidase is inhibited by allylamines. Okay, so this is a class that we will talk about later on. Now, lanosterol is converted to, let's say, another intermediate via a cytochrome P450 which is called a 15 alpha demethylase. برضه رح نحكي كمان عن this enzyme, what it does, how it does so, and the major, and this enzyme is considered a target for خلينا نحكي a very important class of antifungals اللي احنا بنسميهم الأزولز. This enzyme simply demethylates, or in other words, it removes that methyl which is on carbon 14, as the name indicates, 14 alpha demethylase. It removes that methyl and converts it into, let's say, a double bond, or it inserts a double bond into the structure of lanosterol. Okay, this is also a key step, very important. This enzyme is a target of azoles. And later on, many steps happen afterwards that eventually give rise to ergosterol. بس احنا بالbiosynthetic pathway we are only concerned about those two steps which are the target of some antifungal drug classes. مش مطلوب منكم اطلاقا تحفظوا الستركتشر في سكوالين، ايش بصير عندي consequently، يعني that biosynthetic pathway is just a reference for you، مش رح تنسألوا عنها بتفاصيلها. تمام؟ Now نحكي هلا عن أول class which is البوليينز، واللي حكينا انهم they bind to ergosterol. Okay, هلا the members that we will be talking about are amphotericin B, nystatin, and natamycin. All right. Now, if you look at their structures, do you think these compounds are natural compounds or synthetic compounds? Yeah. Looking at their complexity, they are, let's say, natural compounds. Can you describe them? Yeah, they are what? Are they cyclic structures or acyclic structures? Cyclic, all right? What is the functionality of that cyclic structure? Is it a hydrocarbon cycle? What is it then? A lactam, lactone? How this cycle is conjoined by what? Carbon-carbon covalent bond, an ester bond, an amide bond. Ester, okay? Because it's a cyclic ester, which we call a lactone. So these macrocyclic lactones. تمام? What else? هل the size of the cycle is the same in all of them? Which you think is bigger? Amphotericin B, nystatin, and what about natamycin? Yeah. So the size of those cycles of those polyenes which have antifungal activity differs. For amphotericin B and nystatin, they are 38 membered. يعني the number of atoms constituting that macrocyclic lactone is composed of 38 atoms, and natamycin is a 26 membered. Okay, طيب, can you describe those drugs as being lipophilic or hydrophilic? What do you think? شو رأيكم? Yep. So as if the compound has two sides. One is lipophilic. As you can see, we have, let's say, this side of these molecules that is composed of alternating double bonds. ممكن يكونوا conjugated completely or not. The number of double bonds differ. For amphotericin B, it's 6, as for 7. For nystatin, around, let's say, 6 double bonds. And as for natamycin, let's say 4 on this side. Okay? The other side of the molecule has a series of hydroxyl groups, all right? The number, the position, the configuration differs from one to another, but you can, let's say, simply describe it as if I have one side that is completely lipophilic and the other side that is, you can describe as being hydrophilic because of the many hydroxyl groups that are in the structure. مين أقرب structurally لبعض؟ الأمفوتيريسين B والنستاتين الفاريشنز ما بينهم أو الناتاميسين is somehow different. هلا بنحكي عن some of the variations between them. What also is found in all of them is that we have, a sugar part or an amino sugar part. Does it have any ionizable group? Yes, that amino group that is part of this amino sugar, which we call mycosamine, is an ionizable group. Do we have any other ionizable group in the structure of those, let's say, antifungals? Yes, all of them have a carboxylic acid. So بما إنهم they have two ionizable groups, one is basic and the other is acidic, or in other words, they are zwitter ionic, أو في another synonym for zwitter ionic, which is amphoteric. That is why, let's say, for instance, the first one that was isolated is called amphotericin B. هلا natamycin differs from nystatin and amphotericin B is that it has an epoxide and trans because the configuration at the two carbons of this epoxide are, let's say, opposite to each other. Also, it has an alpha beta unsaturated double bond that is conjugated with this ester carbonyl. طيب. هلا in this image in here, this is the structure of amphotericin B, which is depicted here as this gray oval structure. Cholesterol, which is colored here in green, is the one that is represented by this green rectangle. All right? And those, let's say, two blue dots represent the amino sugar that is at physiological pH will be positively charged, and that hydroxylin here. Okay? هلا بما انه حكينا الامفوتيريسين B او those polyenes that we have discussed, they have a part, او خلينا نحكي half of their structure is lipophilic in nature and half is hydrophilic in nature. So what they found out انه هاي polyenes do not bind to enzymes or proteins. What they do is that they bind to cholesterol, اسف ergosterol. When they bind to ergosterol, برأيكم أي part of the amphotericin B هو اللي راح يعمل interactions مع الكوليسترول مع الإرجوستيرول؟ اللايبوفيليك part outside ولا الهيدروفيليك side؟ اللايبوفيليك side, all right? So as you can see, that lipophilic side of amphotericin B is forming, let's say, interactions with the hydrophobic ergosterol. And what happens is that those aggregates of amphotericin B and ergosterol, eventually they will aggregate even more, forming what looks like a pore. And that pore inside, يعني بيكون خلينا نحكي this is the cholesterol side, the lipophilic side, and as for the hydrophilic side, بيكون pointing, let's say, toward that porin, which allows for the passage of what? For sure راح يكون عندي media inside is aqueous, and anything that dissolves in water, amino acids, let's say anything that is considered water soluble, ions, any of those can easily pass through those porins. يعني in other words, eventually those polyenes, as if they form holes in the structure of the cell membrane of fungi, which will leak everything that is inside that can fit that pore. And for sure that is considered hydrophilic. Okay, which will eventually disrupt the structure of that cell wall of the fungi and eventually will lead to the rupture and the loss of everything that is needed for the survival of those fungi. Okay? هلا luckily, as we have mentioned, the affinity of those polyenes for ergosterol is much more than that of cholesterol. طبعا at very high doses وأحيانا for some of those, if given parenterally, they might be toxic. يعني صح في variation ما بين الإرجوستيرول وما بين الكوليسترول affinity to the polyenes, لكن still some of them, even at therapeutic levels, they can be considered toxic لأنهم they can bind to cholesterol and affect our own cell membranes. Okay? طيب. لا بما إنهم they are, let's say, structurally part of their structure is lipophilic, part is hydrophilic. Do you think those compounds, if taken orally, they can be absorbed well? Can you give me, let's say, reasons for that? برأيكم ليش الابsorption لهم ما بيكون, let's say, good? Yes, they have a very high molecular weight. يعني even if they, let's say, can, يعني حتى لو افترضنا انه if taken orally they can pass, let's say, or they can approach a cell membrane, dissolve in the cell membrane, like, and still they have a very high molecular weight that may prevent, let's say, their passage through the cell membrane. And add to that, they are considered zwitterionic molecules. Okay? يعني their aggregates will not allow for خلينا نحكي the cancelling of those charges اللي موجودة عليهم. All of them, if taken orally, it's for the purpose of, let's say, treating fungal infections locally. And for sure, they can be used topically. Only amphotericin B is given parenterally for treating systemic fungal infections فقط. مش لأنه النستاتين والناتاميسين cannot be prepared for parenteral, let's say, preparations. لكن مشكلة those two drugs, النستاتين والناتاميسين, they are toxic at therapeutic levels. Something that is noticed or that was found for amphotericin B when taken, let's say, if given parenterally, that it may affect or it leads to contractions or constriction of the afferent arteriole in nephrons, which will change, let's say, the pressure in the kidneys. And also it affects, let's say, the cell membranes of the distal tubules, which will leak many ions such as potassium and sodium. Amphotericin B, if given parenterally for treating systemic infections, it does have one of its main issues is that it leads to nephrotoxicity. طيب ننتقل هلا another class, which is the azoles. We are still talking about the drugs that are, let's say, interfering with ergosterol. لكن for azoles, they are interfering with azole biosynthesis. Okay? هلا remember إنه حكينا the enzyme that the azoles affect is called 14-alpha demethylase. The crystal structure you see here in front of you is for 14-alpha demethylase bound to lanosterol. Lanosterol is the substrate for this enzyme. Okay? طيب هلا what is represented in green is the protein structure of this enzyme. And as for what is represented in blue represents lanosterol and something else. Can you tell me what is the other thing? يعني هاي البلو structures اللي شايفينها هون. Which one represents lanosterol? Which has a steroidal backbone. Yes, this one in here, this is lanosterol. But what do you think the one at the bottom? What is this? شو رأيكم؟ بذكركم بإيش؟ When you have a transition metal that is bound by atoms which are part, let's say, of cyclic structures conjoined by covalent bonds. What does it look like? It's a heme. Okay? That transition metal in here is iron, which is conjoined with a heme. And this is a molecular oxygen, that's O2. والهيم زي ما كلنا بنعرف, all right, it binds to molecular oxygen. And what it does, it generates, let's say, oxides that eventually will lead to oxidation. هلا في حالة اللانوستيرول, when it binds to 14-alpha demethylase, هالإنزيم شو بيعمل? As the name indicates. Yes, it binds to, or it طبعا approaches اللانوستيرول, in particular carbon أو الميثيل group اللي موجودة عندي على carbon 14, and eventually it demethylates it. هلا حتى نفهم الفانكشن of the azoles ضروري إنه نعرف how it does so. In the figure you see in here, this is the heme part, which is a cofactor bound to 14-alpha demethylase. And what you see in here is lanosterol. That's the substrate that the enzyme removes the methyl from carbon 14. That is bound, let's say, to carbon 14. Okay. Now the heme, or the iron in the heme, is bound usually to molecular oxygen, or it can easily bind to molecular oxygen, giving rise, let's say, to activated form of this molecular oxygen. Now, when it approaches the lanosterol, what happens easily is that the methyl group that is bound to this to carbon 14 in lanosterol, all right, it gets oxidized. When it binds to the molecular, to the activated form of the molecular oxygen, it gets oxidized into what? Into an alcohol. Is there any further oxidation of the alcohol? هل ممكن يصير عندي further oxidation of the alcohol؟ لا إيش؟ Exactly. So what happens is that that alcohol is later, by the same heme, is converted to an aldehyde, and that aldehyde leaves, or that carbon will leave, let's say, this compound in the form of formic acid, and a double bond will form between carbon 14 and carbon 15. هاي الميكانيزم احنا مش يعني interested او مش ضروري انه احنا ندخل بتفاصيلها. So what happens easily is that lanosterol, when it binds to 14 alpha demethylase, the heme part in 14 alpha demethylase oxidizes the methyl bound to carbon 14 into the alcohol that is further oxidized into the corresponding aldehyde that then, let's say, is removed in the form of a formic acid, and the double bond forms between carbons 14 and 15. All right. Now, with azoles, this drug class, you think they are named azoles because they have a ring that has, let's say, nitrogens in its structures. يا إما بيكون في عندي 2 nitrogens أو 3 nitrogens. هلا if I have a 5-membered aromatic ring that has 2 nitrogens, هاي إيش بسميها أنا؟ imidazole. And if it has 3 nitrogens, triazoles. So this is the pharmacophoric part in those azoles, is that they have a 5-membered aromatic ring that has either 2 or 3 nitrogens, basic nitrogens. All right? هلا, for sure, one of them is the one that will coordinate with the iron in the heme, which will prevent any lanosterol from binding to 14 alpha demethylase, or eventually it will inhibit the synthesis of ergosterol. All right? Here's a crystal structure of 14 alpha demethylase bound to one of the azoles, which is fluconazole. Tamam? Here is the entire enzyme, and here is a zoom in على الهeme part. All right? This is the heme, this is the iron, and as you can see, there's a coordination bond that is formed between the iron and the azole ring. Is it an imidazole or a triazole? It's a triazole because I have 3 nitrogens in the structure. Tamam? All right? So that's the core part in all azoles that act as antifungals. They need to have an azole ring in their structure in order to bind eventually or to coordinate with the iron in the heme. This is how they will prevent lanosterol binding, and when you prevent lanosterol binding, you will eventually inhibit the ergosterol biosynthesis. But what they found out in the toxicity coming from the azoles is not only because the ergosterol is depleted, وإنما when lanosterol is not converted eventually to ergosterol, شو رح يصير فيها؟ Accumulation. No lanosterol will be converted, يعني still squalene is eventually converted into into lanosterol. لكن lanosterol, because the enzyme, the 14 alpha demethylase is inhibited, it will not be eventually converted to the corresponding ergosterol. فبصير في عندي depletion بالergosterol وبرضه راح يكون في عندي accumulation of lanosterol. هلا what they found out إنه the accumulated lanosterol or the increased levels of lanosterol may eventually bind to the cell membrane instead of ergosterol that is depleted. This will lead to changing the permeability of the cell membrane, and that change in the permeability will lead to the leakage of the essential ions and eventually the death of the cell. Okay? طيب, هل في any other enzymes that has the heme in our cells or in our body? Do we have enzymes that are abundant and that they have the heme group in their structure? red blood cells الهيموغلوبين. تمام. what else؟ الcytochrome P450 family, right? Cytochrome P450 family, they all act via, or their action has to do with the heme group that is part of their structure. So similar to 14 alpha demethylase, if those drugs can bind to 14 alpha demethylase, they also have the ability to bind to the cytochrome P450 family. طبعا الافينيتي لكل drug ما بين one isoenzyme to another in this large family differs. لكن you can say generally إنه الأزولز they do or they highly affect the activity or the action of cytochrome P450. That is why we need to take into consideration that when those drugs بالذات اللي طبعا for sure for those that are used for treating systemic fungal infections, they need to be, or care need to be taken when they are co-administered with other drugs, okay? Because they will highly and definitely affect the cytochrome P450 family. So if the co-administered drug, okay, if the dose is eventually calculated based على what is eliminated via metabolism, if co-administered with azoles أكيد بالنهاية الدوز راح تختلف. على سبيل المثال, if azoles are combined with phenytoin, okay, the blood levels of, let's say, phenytoin will rise if, let's say, co-administered with those azoles. لأنهم simply the enzymes responsible for its inhibition will be, let's say, inhibited. Okay. طيب. نحكي هلا عن الSAR regarding الأزولز. So far حكينا إنه الفارماكوفوريك part is the azole ring, يا إما الإميدازول أو التريازول. Okay. طيب. Is this group ionized at physiological pH? الPKA راح تكون أقل من 9 و8 برأيكم؟ يعني versus aliphatic amines راح تكون أقل ولا أكثر؟ طيب خلينا عشان هيك to reach a conclusion خلينا نعتبر إنه we are talking about the basicity of this nitrogen, the one that has a lone pair of electrons that is localized, okay, relative to aliphatic amines. بين 8 وال10 الاليفاتيك امينز يس لكن what about let's say الازولز او that nitrogen in imidazole or triazole localized right لكن هل راح تكون البي كي اي ممكن توصل 8 و10 لا هي راح تكون اقل بكثير كمان يعني ممكن توصل up to 5 4 something like that طب why is that بما انها اقل البي كي اي معناها high nitrogens less basic or more basic than aliphatic amines? Less basic, okay, with a great magnitude. يعني احنا لما نحكي for instance from 9 to 5 or 9 to 4 احنا بنحكي عن 1000 times or 10,000 times less basic. Right? Why is that? مع انه lone pair of electrons in this tautomeric form او حتى in this form راح يكون عندي localized. If you compare it, for instance, with this, تفضلي. تفضلي. على 2.4. هاي مادتك؟ هاي محاضرة من أول الفصل وهي هون يعني. لا it's fine ما في مشكلة. it's fine ما في مشكلة. طبعا for sure. لا بسيطة. لا أبدا. طيب. هلا for instance let's compare it with this one. أنا عندي هون lone pair is localized و this lone pair is also localized. How come this one تقريبا ال PK is around 9 and this one is around, let's say, 5? هلا لو بده يصير في resonance بصير بهاي الطريقة. Yeah, it doesn't have to do with this lone pair. What is the hybridization of this nitrogen? Where is this lone pair? What is the orbital that holds this lone pair? sp3, all right? طيب, here, this lone pair, or this nitrogen, is also sp2 hybridized, or not also it's sp2 hybridized. A lone pair is sp2. Localized, okay, well, lone pair has nothing to do with the p orbitals that are part of this, let's say, resonating system. يعني localized, all right? So resonance يعني برفعها مثلا مقارنة ب for instance لما تحكي انت البيرول، يعني ال pKa for this nitrogen أعلى من البيرول، لكن still البيرول و this one, all right, yes. والبيرول حالة مختلفة كمان، يعني بيكون اللون بير مش localized actually. طيب هلا مين if you compare ال sp2 versus ال sp3, if you compare those two orbitals, أي من هاي الاوربيتالز بيكون اللون بير اللي فيها أقرب للنيوكليوس؟ Which one? sp2. ليش؟ لأنه فيه less p character, more s character, more spherical, closer to the nucleus. Okay? فالإلكترونز اللي موجودين عندي in an orbital that is sp2 بتكون هاي الإلكترونز أقرب للنيوكليوس versus الإلكترونز اللي موجودة عندي ب sp3 orbital. Okay? فبالتالي مين عنده liability إنه يعطي its electrons more? Yes, that nitrogen that is sp3 hybridized. فالsp2 لانها more s character الالكترونز اقرب لها رح يكون اصعب لها انها تعطي its electrons, فذات is why بتكون عندي less basic, alright, that is why ال pKa بتكون عندي اقل. شكله هاي القاعة حاجزينها لمحاضرة ثانية فذات is why يا عم في ميك اب اليوم، بس الميك اب على 2:30. alright. طيب another thing that is, let's say, common in azole antifungals is the presence is that they need to have aromatic rings. ممكن يكونوا, let's say, 2 up to 3 aromatic rings, and even in some cases more than that. هلا at least one of those aromatic rings that are part of the structure must be, let's say, halogenated. Okay? هلا they found out انه the halogens that are optimal for activity او اللي بيعطوني the best antifungal activity is when I have, let's say, fluorines. Okay? طيب لما يكون عندي many aromatic rings بالsystem, would this make the drug if taken orally easily absorbed? Do you think انه their water solubility راح تكون عالية او enough for, let's say, good absorption? Yep. Yeah. هلا such a drug, for instance, that has an azole ring alongside 3 aromatic rings, or in particular لما تكون عندي one of them halogenated, these drugs are highly lipophilic. Okay? Now, the changes that they've made, which gave rise to enhancing the water solubility, is what we see in fluconazole. The fluconazole, as you can see, it does have a ring that is an azole ring, which is specifically called the triazole, okay, and not just 1, 2. It has, let's say, this aromatic ring that has a fluorine substituents. Now, الفلوكونازول بيختلف عن other azoles اللي هلا راح نشوفهم, إنه because of having those, let's say, 2 azole rings or those triazole rings along with the hydroxyl group in its structure, the fluconazole has enough water solubility, let's say, that will make it possible for this drug to be generated as, let's say, an IV injection. Here is, let's say, a list of all of the azoles that are FDA approved. Okay, here they are classified into those which are used topically for treating cutaneous mycosis, and those can be administered, let's say, for treating systemic infections. Okay. As you can see, all of them has that pharmacophoric azole ring, يا إما بتكون an imidazole or a triazole ring that is very important for binding to the heme in the 14-alpha demethylase. Also, all of them, as you can see, have an aromatic ring that is halogenated. Okay, يا إما one halogen part of their structure أو two halogens ممكن يكونوا chlorines وممكن يكونوا fluorines. Okay. These are the main two parts اللي احنا راح نركز عليهم in terms of the SAR. But as you can see, the rest of the structures for those azoles vary significantly between them. يعني you cannot exclude or خلينا نحكي you cannot extract an obvious SAR for them. الconnectivities ما بين الatoms والfunctionalities والrings تماما تختلف from one member to another. The one that we have said has enough water solubility for it to be prepared for IV injection اللي هو الفلوconazole. Its water solubility can even be further enhanced by generating fluconazole or generating a prodrug that is a phosphate prodrug. واللي for sure, as you all know, that phosphate can be easily removed in vivo via alkaline phosphatases. Okay. الفوريكونازول شو بيختلف عن الفلوكونازول؟ Instead of having two triazole rings, one was substituted with a fluorinated pyrimidine. All right. هلا الفوريكونازول, they found out it has very good activity against the resistant strains of fungi. And resistance not only seen in bacteria, but also seen in fungi. Voriconazole, for some reason that is not yet well established, it can, let's say, affect ergosterol biosynthesis in the resistant strains of fungi. طيب نحكي هلا عن آخر class that is involved in inhibiting the biosynthesis of ergosterol, which is الاليلامينز. هلا لما نحكي اليلامين معناها those drugs have an amine, okay, in their structure, right? And when we say allel, yeah, it is, let's say, actually الallel, it is relative to a double bond. هلا لما تكون عندي that functionality is bound to a double bond that is, let's say, one carbon away from it, this is called an allel position. Okay, لما تكون directly attached to it هنسميها vinyl. All right. هلا التولنافtate is also a drug that inhibits ergosterol biosynthesis via the same mechanism as naftafen with terbinafine, which are allylamines. لكن it does not have that, let's say, it is not considered an allylamine. Actually, high functionality. Can you guess what its name? And it has a functionality completely different from those allylamines. Can you guess what is this functionality? طيب لو عملت هاي O. Carbamate, okay? When you convert or when you, let's say, substitute a sulfur with oxygen with a sulfur, still carbamate, بس لما أغير أنا الأكسجين with a sulfur, it will be called thiocarbamate. All right? هلا النافتفين, التربinafine with tolnaftate, all of those drugs, they inhibit, as you can see, the squalene epoxidase. They bind to that enzyme, which its substrate is squalene, and thus they inhibit the epoxidation, which is necessary later on for the synthesis of lanosterol. Okay? Those drugs can be used, let's say, topically. Only terbinafine can be used orally. النافتفين, and even though يعني it can be used orally for treating a systemic infection لكن الابsorption بيكون جدا 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 قليل. So that is why النفتفين is only used topically, and for treating systemic infections terbinafine is the one that is used for those systemic infections. طيب رح نحكي هلا عن inhibition of the glucan biosynthesis. الجلوكان as I have mentioned يعني ممكن نعتبره احنا مرادف للبيبتايد وجلايكان في البكتيريا. Okay. The glucan is a homopolymer. يعني it's a polymer that is composed of, let's say, polymerization of glucose units. يا إما they are bound via a 1,4, a glycosidic bond that conjoins carbons 1 and 4, أو ممكن in some cases يصير في branching via combining الhydroxyls from اللي موجود عندي على carbon 6 و carbon 1. Okay. هلا the enzyme responsible for the synthesis of a glucan or the polymerization of those glucose units to give eventually the glucan is called glucan synthase. The glucan synthase is an enzyme that is membrane bound. يعني بيكون عندي هالenzyme part of the cell membrane, the inner cell membrane of fungi. What it does simply, it binds to the glucose and eventually it polymerizes those glucose units, giving rise to the glucan. Okay? هلا the only drugs that are known to inhibit the glucan synthase اللي هم اسمهم الechinocandins. Again, if you look at their structures, those FDA approved echinocandins, are they, let's say, you think natural compounds or synthetic compounds? Yeah, these are actually semi-synthetic. They are derived from, let's say, natural sources, but this, this lipophilic part that is bound to them is actually added semi-synthetically. Very complicated structures. They are actually cyclic peptides, because if you look at, let's say, these parts, these are actually amide bonds that conjoins, let's say, amino acids together. So it's a cyclic peptide. Okay, they do inhibit to the glucan synthase, and they bind to it and they inhibit this glucan biosynthesis. آخر member رح نحكي عنه اللي هو the flow cytosine, which is considered the only anti-metabolite that is used as an antifungal agent. The flow cytosine, when absorbed inside the fungal cells, it is converted to 5-fluorouracil. 5-fluorouracil وين مر عليكم؟ بالanticancers, exactly. هلا الفلو cytosine is converted inside the fungal cells by cytosine deaminase into 5-fluorouracil. All right. هلا this drug can be used safely as an antifungal, does not affect our cells, as you all know, because simply the passage of flow cytosine inside the cells requires cytosine permease, which is absent in mammalian cells. We do not have that carrier, only fungi have that carrier. So that is why the flow cytosine does not enter our cells, is not converted to 5-fluorouracil. Otherwise, it will not be safe at all. Okay, now inside the fungal cells, the 5-fluorouracil is converted into the active form, which is the 5-fluorouridine monophosphate. That is, let's say, as you all know, it inhibits a thiamidylate synthetase, and by inhibiting a thiamidylate synthetase, it will inhibit a DNA synthesis, can be incorporated into RNA, and when it's incorporated into RNA, definitely راح يصير في عندي mistranslation and inhibition of protein synthesis. Okay? Any questions so far about the antifungals? So this is what you need to concentrate on. If there is any information pertaining to pharmacology بهالslides, don't worry about it. احنا interested فقط بالmechanisms of actions وبالذات if it has chemistry involved in it, and for sure the SAR and the structures of those different classes of the antifungals. اللي موجودين online في أي حدا عنده أي سؤال؟